Okay, class, I'm going to do numbers 15 and 17 from the 9.6 day 1 homework, which is graphing polar conics. So the first one was r is equal to 8 over 4 plus 3 sine theta. And the first thing you want to do is turn it into the formula that we know just so we can analyze it. So if we divide everything by 4, we get 2 over 1 plus 3/4 sine theta. Since e is less than 1, because e is equal to 3/4, remember we get our e value here, then we know that this is an ellipse. And you can get the p value too, because 2 is equal to e times p, but again, not important for what we want to do. I was just showing you that it's more important for the directrix, for parabola. But since this one's not a parabola, we don't really care as much. So what did I want to show you? And then when you graph it, just to double check, you should see that the major axis is the y-axis. So when we get our vertices, we'll know that A is in that direction. So let's do that first. So I think my thing stopped, but now it started again. So anyway, we're going to do our chart, our theta, and I'm going to do theta 0, 90, 180, 270. You could also use radians. And plug it into the original is probably easier actually. So when you're at 0, sine is 0, r is 2. When you're at 90, sine is 1. You're at 8/7, which is not the nicest number, which is probably why you guys want me to do this one. Sine of 180 is 0, so we're back at 2. And then 270, you get -1. So you get -3, so 4 minus 3 is 1. So you get an 8 in that direction. So if I'm graphing this, I have 1 there, 1, 2, 3, 4, 5, 6, 7, 8. I have a point here. I have a point at 8/7, which is a little bit higher there. I have a focus. Hopefully you guys are now in 7th period and are not late. You have a focus at 0, 0. You have your two vertices, you could already say, are at, this is 8/7 at 90 degrees, or pi over 2, and the other one is at 8 at 270 degrees, or 3 pi over 2. So I already have 3 of the pieces I need. Now I need to find the center. So you always use your vertices to find the center. Now there's 2 ways to do this. You can just add these numbers, divide by 2 to find the entire length of A, to find the A value, and then use that to find the center. Because remember, this whole length divided by 2 is the A value, because A value is from center to the outside. Or you can do a midpoint by using the negative and positive. Either way you want to do it. So I'm going to do it this way, where I add them. And when you add these and then divide it by 2, you get a fraction of 32/7, which is your A value. So I know A is 32/7. So now I have to figure out where my center is based on that. Well, if I'm here, I want to move 32/7 this way, which is subtracting from 8. So to find the center, I'm going to do 8 minus 32/7. And when you do that, you get that the center is at 24/7 in the, again, 270 degree direction. Okay, so 24/7 is what? 21/7 is 3, a little bit more than 3. 1, 2, 3, about right there. And sure enough, that looks like that is about center. So now I have the center, and I know I have the point 24/7. And 24/7 also happens to be the C value, because if we're moving from the center up back to the 0, that is 24/7. So my C value is 24/7. Which means my other focus is down here. You add 24/7 to 24/7, and you get 48/7, which is a little bit less than 7. So my other focus is then at 48/7, comma 270. So I have the two foci, the two vertices, the center. I have all 5 pieces for this ellipse. I need to find the B value, and you get that 24/7 squared is equal to 32/7 squared minus B squared, and from there you can just solve, and you get B is approximately Oh, I don't even know because I don't have my calculator out. I think it was something like 3.01 or something. Let me do that real quick for you guys. Off camera. I hope everyone's day is going well. And then square root, oh. Yep, 3.02, so about 3.02. So if I just am doing this just for graphing purposes. Oh, we could have also got the points up here as well. There are two other points. We have 2, 0. We did get those points. I just didn't graph them. We know that that exists there and there. And then the actual graph goes to about 3.02, which is there, and about there. But I don't want the polar points of those. You don't have to do those. It just helps with the graphing. So this is the graph of this ellipse. And I think that's it. And then the only thing you would have to do is convert this like we did today into rectangular, but I'm not going to spend time doing that. I think you guys know how to do that. I have all my 5 pieces. So let's do 17 and then we'll call it a day. So 17 is r is equal to 9 over 3 minus 6 cosine theta. If I turn that into the correct form, we divide everything by 3, which means that e is equal to 2, which means that we have a hyperbola. And again, you can graph it to see what it looks like. Let me pause and get that up real quick. Okay, so I'm back. I'm graphing it right now. As you can see, the hyperbola is right there. So the vertices are to the left of the pole. So we know that those will be our points. So we'll get to that in a second. I just wanted to see what it looked like. Alright, let's do this. We got r and theta again. We want our thetas of 0, 90, 180, 270. When you plug 0 in for cosine, you get 1. 1 minus 2 is negative 1. You get negative 3 at the angle of 0. At 90 degrees, you get 3, because it's 3 over 1. At 180, this becomes a negative 1, which means it's a negative negative 2. So it's 3 over 1 plus 2, which is 3 over 3, which is 1. Okay, again, I just plugged that into there. I know I spoke fast there, but that is what it evaluates to. And then 270 again, we get, plug that in, you get a 0, you get 3. Alright, so those are my points, so I'm going to graph this. What I have, I know that I have the point in the 0 direction, negative 3, which flips over, so one of my vertices is right there. Again, our focus is right here, so focus. Please don't forget to put 0, 0, and something else we'll deal with later. One of the vertices are at, you can call this 3 comma pi if you want, or 3 comma 180, or you could say negative 3 comma 0 because it flips it over. The other one is 1 comma 180, or pi. One thing I do want you to do, if you're going to either use all degrees on this or radians, don't just try to mix and match. It looks sloppy. So we have those. Now we can find the center. This one you can just eyeball. We're at 1 and 3. The center must be here at 2. So the center is at 2 comma pi, which means our A value is the distance from the center to the red dot, which is 1. The focus to the center is 2. So now we know where the other focus is. It's 2 away, right here, at 1, 2, 3, 4 comma pi. So now I've filled in all 5 of the points I need. I also know the other 2 points. I can just kind of graph them real quick. At 90 degrees, we're up 3. We're right there. And at 270, we're in 3 in that direction too. Okay. I probably should have put those as red because that's the graph we're doing. Now, we need to find the b value to find our box. And we have b squared plus a squared equals c squared. 4 equals b squared plus 1. So b is equal to root 3, which is approximately 1.7. So for my box, I'm moving up about 1.7 in this direction. So about there and about there. So now I have my box. I have my asymptotes that go through the center and the corners of the box. And now I can graph my hyperbola. You don't need points over here. You can just kind of graph it. And the last thing I need are my asymptote equation, which is the slope, which is rise over run. The rise in this case is the b value, or root 3. The run is 1. So my slope for my equation is root 3 over 1, or plus or minus. And then the center, and I want this in rectangular. This rectangular coordinate is at -2, 0. So that means that if I do slope or point slope form, it's y minus 0, or y, equals plus or minus root 3 times x plus 2. And these are the asymptote equations. And then again, I might ask you to convert the equation into rectangular form like we did today on the notes, but I'm not going to go through that. You guys. Okay, so that is it. Hopefully that helps a little bit. Again, key for these two, for ellipses and hyperbolas, find the center from the two vertices you get from your finding them from plugging in thetas or looking at your calculator. All right, good luck tomorrow. Study hard. If you have questions, post them on Canvas, and that's it.